The following is the video solution from JSDT Solutions. Question 10.1 says, A and B are independent events. Okay, the probability of A is 1 over 3 and the probability of B is 3 over 4. And we need to determine the probability of A and B. Okay, so from independent events, we know that if events are independent, then the probability of A and B is equal to the probability of A multiplied by the probability of B. So this is going to be equal to 1 over 3 multiplied by 3 over 4. And then from here, you see that 3 and 3 will cancel and you'll just be left with 1 over 4. And that is our answer. Question 10.1.2 says, we need to calculate or determine the probability that at least one event occurs, at least one. So we only have 2 events here, okay? And they say the probability that at least one occurs. To interpret this really just means that either A could occur or B could occur. And that's really what they want. They want the probability of A or B. So this is what we have to find. Now, the calculation for the probability of A or B is the probability of A plus the probability of B minus the intersection. And the reason we subtract that intersection is because if we don't, it ends up being added twice. It has to do with really the Venn diagram. If you have A and B and you say the probability of A, everything here, plus the probability of B, everything here. You see, the problem here is that you already added the intersection. The first time we said the probability of A, it included that intersection. But then you said the probability of B, and it also included that intersection again. So we have to subtract by that intersection so that it can only include one of it. That's the whole point of that. Okay, so this is equal to, and we have these calculations. We have A and B over here. Okay, so A is 1 over 3 and B is 3 over 4. So plus 3 over 4 and then minus 1 over 4. And that would be our answer. So let's see. Okay, just to save time, we put that on the calculator and that is 5 over 6. And that is the probability that at least one event occurs. Question 10.2 says, the probability that it will snow on the Drakensberg mountain in June is 5%. Okay, so probability that it will snow is 5%. Then they say, when it snows on the mountains, the probability that the minimum temperature in central South Africa will drop below 0 degrees Celsius is 72%. So this is when it snows. On the condition that it snows, the probability that the temperature is going to drop below 0 degrees is 72%. So when they're giving us this type of information, if it snows, then this is the percentage that it's going to snow. Because it's a situation where they're showing you that the probability that it will snow is 5%. So you know that the probability that it will not snow will be the difference, which is 95%. And then they're saying if it snows, okay, so just say 95% and then say not snow. And then they're saying when it snows on the mountains, the probability that the minimum temperature is going to drop below 0 degrees is 72%. So this is the probability. The condition that they're referring to is the temperature dropping below 0 degrees. So when it snows, we're going to follow the branch where it snows. And now they're telling us that the probability that it drops below 0, so we can say below 0, okay, is going to be 72%. And so we'll be able to find the probability that it will not drop below 0. Let's just call this below Z, okay? And then not below Z, okay? And yeah, that will be the difference, okay, which would be 28%. Okay. Okay, so I've just decided to change that 0 degrees to an actual 0 degrees. And then we have, if it does not snow on the mountains, that's the not snow part, the probability that the minimum temperature in central South Africa will drop below 0 degrees is 35%. So on the condition that it does not snow, the probability that the temperature would drop below 0 degrees. Okay, so that is below 0 degrees. The probability of that is 35%. So if this is 35%, then it means that the probability that it will not drop below 0 degrees would be the difference, which would be 65%. Okay, so not below 0, 65%. Okay, because that's what will help it add up to 100%. Okay, so yeah, they say represent the given information on a tree diagram, clearly indicating the probabilities associated with each branch. These are the probabilities associated with each branch. They didn't say anything about stating the outcomes, so we'll leave that. And this is our answer. Question 10.2.2 says, calculate the probability that the temperature in central South Africa will not drop below 0 degrees in June 2024. Okay, so we're looking for the probability that it will not drop below 0. Notice the places where we have not below 0. That's here and that's here. So we're going to take the full probabilities. This has a lot to do with the outcomes. When you're looking at the outcomes of everything, you're going to look at them across their branches. So the outcomes that we'll have here. So we'll have a situation like this, where we can say the probability that it snows is 5%. And then given that it snows, the probability that the temperature will drop below 0 will be 72%. So the outcome we'll have here is it snows and the temperature drops below 0. And we could find the probability of this simply by saying that 5%, which is 5 over 100, multiplied by 72%, 72 over 100. So we just multiply their outcomes. Now we could multiply each and every outcome, but let's actually just stick to what they want. They want the probability that it will not drop below 0. So we're only going to look at these ones. So you see this not below 0, it was the result of if it snows, the probability that it will not drop below 0 is 28%. We're going to have to put them together because they are a single outcome. So that is the probability that it snows and the temperature does not drop below 0 degrees. So that will be not below 0. We'll take that, okay, and that you can see is going to be 5%, 5 over 100, multiplied by 28 over 100. And then the second place where we see not below 0, because we're going to just take all the places where not below 0 occurs. And that will be over here. So this is when it does not snow. Probability of not snow. Okay. And again, the temperature does not drop below 0. And we would just find out what that is. So this was 95. I don't know why I said 9.5. 95%, 95 over 100 multiplied by 65%, which is 65 over 100. So we are going to take these and we're going to add them because that would give us the total probability that the temperature will simply just not drop below 0 degrees. Okay, and now that we have that, we're going to add these together and that will give us our answer. And the answer is, we can just put this in decimal form. So it's a long answer. I would actually leave it as a fraction. It is 1263 over 2000. Okay, so that is our answer to 10.2.2. Question 10.3. 10 learners stand randomly in a line, one behind the other. 10.3.1 says, in how many different ways can the 10 learners stand in a line? Okay, you just have 10 learners, 1, 2, 3, 4 to 10. And we're just seeing the different ways that they can stand in this line. So the first learner has 10 different places to stand. They can either stand here in position 1 or 2, 3, all the way to the 10th position. Once the first learner is standing, the second learner has 9 more places to stand in. So 9 choices. And then the third learner, 8, then 7 choices, 6, 5, 4, 3, 2, and 1. So you can see that to find this is simply 10 factorial, which is equal to, so this is 3,628,800 ways. Okay, so they said in how many different ways, that would be the total ways. Okay, moving on to the next question. And the last question says, calculate the probability that there will be 5 learners between the 2 youngest learners in the line. So let's keep in mind that at the end of the day, we need to find this as a probability. Okay, that there will be 5 learners between the 2 youngest learners in the line. Okay, so it means the 2 youngest learners are 2 specific people. And we can just look at the placements and how they can be standing. So youngest learner, we can call them youngest learner 1 and youngest learner 2. So youngest learner 1 could first be in the first position. Let's just remember that there are 10 places. So the first youngest learner could be in this first position. And then there needs to be 5 learners in between. So 1, 2, 3, 4, 5. And then the second youngest learner can be here. Okay, youngest learner 2. So looking at it like that, and then, we're going to have the other learners behind here. We're going to have to look at all the placements that we can have. It's not really the type of question where we can say, okay, we're going to ensure that there are 5 learners here, because these are not 5 specific learners. They didn't name 5 specific learners and say that these specific 5 learners need to be in between the first youngest and second youngest learner, or the 2 youngest learners. So we need to also consider that they could be anyone. It could also be a learner that is currently here that could be seated here, as long as there are 5 learners in between them. Okay, so looking at these placements, we could have it looking like this. Or another way that they could be placed would be like this. So in this case, youngest learner 1 could sit here instead. So instead of this learner being here, or any learner really, doesn't have to be that particular learner, youngest learner could be there, the first one. And then the second one, there has to be 5 learners in between them. So second way that could also happen would be like this. And then another way that they could be seated would be where you have 1, 2, 3, and that youngest learner is in the third position, this one of the youngest learners. And then again, you would have 1, 2, 3, 4, 5 places where you have 5 students in between them. And then there is the other younger learner. So see how you had 2 learners behind here? Now you just have 1. Okay, so like that. And then there's one more way they can be seated, because we need to ensure that they occupy places that allows for 5 learners to be in between them. So that would be 1 learner here, another one here, and I know I didn't put circles for them. There are learners sitting there. So, and then another learner here, then one of the youngest learners here, and then 5 learners in between them again, and then the other younger learner. So in this case, there would be no learner behind them. So that would give you a total of 10 learners standing again. So you can see from this that there are 4 ways that they can be standing like this. So for us to achieve this first placement, here's the thing. These 2 learners, they never said that one of these learners specifically has to be in front of the other one, has to be ahead of the other one. No, the first youngest learner and the second youngest learner, they don't have to be seated specifically like this. For example, the second youngest learner could be here and the first one could be here. So looking at their placements and where they are seated, it means that there are 2 ways that they can be sitting like this. Yes, they have 5 learners in between them, but youngest learner 1 could be in the first position and then youngest learner 2 could be in the 7th position, or youngest learner 2 is in the 2nd position and youngest learner 1 is in the 7th position. Okay, so that could happen as well. So there are 2 ways that they can be sitting like that. Okay, so we're done with them. And now let's think about the rest of the students. How could they be seated like that? Remember that these are not 5 specific learners. It could be any of these learners. So this learner, for example, could be here, or this learner could be here. So because of that, we can look at them as a placement of their own. There are a total of 8 other learners left, so the ways they can be seated is like this. This first learner has 8 different places to sit. You can either sit here in the second position, the third, fourth, fifth, all the way to, I won't call that the 8th because this learner is here. But they could be seated in any of these positions, and they happen to be 8 positions left after these 2 learners are seated. So that would be 8, okay? And then we have, after the first learner is seated, the second learner, okay, out of the 8, has 7 more positions to sit at. After that learner is seated, the third one has 6 more positions, and then 5, 4, 3, 2, and 1. So that is 8 factorial. So to find the total seatings, what this would look like, it would be 2 times 8 factorial. And then looking at the second placement, again, these 2 learners, the first youngest and the second youngest, supposing that they're not the same age, they don't have to be seated like that. Okay, so they have 2 total ways to be seated. And again, do you see that the total learners left will be 8 learners? And these 8 learners, this first learner has 8 different positions they can sit at. You can sit here, you can sit here, 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 and that will be a total of 8 positions. Once seated, the next learner will have 7 places to sit at. And once that learner is seated, the third one out of the 8 will have 6 more positions. So that's again a case of 2 times 8 factorial. And then as you look at the other placements, it's the same thing. These 2 learners do not have to sit here. They could sit as Y2 and Y1. So again, it's 2 times the remaining amount of learners. They have 8 different positions to sit at. That will be times 8 factorial. And then again, that's 2 times 8 factorial. So you have 4 sets of this going on. And so to find that, the total ways at first, we'll say 4 multiplied by 2 times 8 factorial. And let's go ahead and find out what that gives us. So that is 322,560 ways. Okay, but this was not the question. That's not the final question. The question is to calculate the probability that there will be 5 learners between the 2 youngest learners. We see the total ways that there can be 5 learners between the 2 youngest learners. So the probability must be over the total, the unrestricted total, which was in question 1. Okay, there are 10 learners in total. If we were just finding out all the ways they could be seated, it was this 3 million and that. Okay, so we're just going to take this answer and divide it by 10 factorial, or that 3 million. Okay, so the probability that we'll have 5 learners between the 2 youngest learners would be that answer over the total ways that they can be seated, which just simplifies to 4 over 45, and we can leave our answer like that. I prefer leaving it as a fraction. Okay, and that is our answer, and that is the last question for question 10.